Hello viewers, in this video we'll be discussing about chapter 8, that is trigonometry. It is an introductory class, so before moving to the exercise problem we should first know what we are going to learn and why do we need to learn this chapter. Only after knowing the meaning of the topic we will know the importance of this chapter and why do we need this in our daily life. After watching this video, I can assure you that you will have a clear-cut idea about the term trigonometry. So let's begin. Let us first start with the meaning of trigonometry. So what does this word trigonometry means? So first I will divide this term into two parts. So this part, this is trigon, and this we term it as metron. So now this trigon and metron is basically a Greek word. So trigonometry has been derived from this Greek word, that is trigon and metron. So what does this trigon means? This trigon means, in Greek term, it means a figure with three sides. So we can say that a figure with three sides is triangle, right? It's a triangle. So trigon means triangles. What about metron? Metron is known as measurement. This Greek term metron is known as measurement. So now basically if we join these two terms, then we can make out the meaning of the topic, that is measurement of triangles. Measurement of triangles. Okay, so trigonometry, under trigonometry basically we are going to learn how to measure triangles. That means the measurement of triangles is what we are going to learn under trigonometry. So I hope it's very simple, right? Simple to understand. Trigonometry means measurement of triangles. So what does, if I try to simplify this term, that is measurement of triangles, so what does this mean? We all know that how a triangle looks, right? So I'm drawing one triangle. So what does measurement of triangles means? Measurement of triangles means we will try to measure, maybe sometimes we will try to measure the length of these sides, like what is the length of AB, like it may be 10 centimeter, 5 centimeter, or sometimes we might use trigonometry to find out the angles, of these triangles. So measurement of triangles means we will try to find out the sides, the length of the sides of the triangle, or the measure of this angle using trigonometry. So this will be very useful tool for us. Like trigonometry will help us to find out the missing length of a triangle or missing angles of a triangle. Now see, when we go back to triangle, this triangle, we have many types of triangles. There are equilateral triangle, there are right angle triangle, there are isosceles triangle. So we have many types of triangle. But under trigonometry, this triangle basically refers to right angle triangle. So what I'm trying to say is that under trigonometry we will measure mostly right angle triangle. It's not that trigonometry cannot be applied in other type of triangles, but as per our syllabus, and then mostly in most of the case trigonometry is applied only on right angle triangles. So you need to remember this. Trigonometry is measurement of triangles, but basically under measurement of triangles we are going to focus mostly on measurement of right angle triangle. So you need to remember this. We are going to measure only right angle triangles under trigonometry. So let us conclude the meaning of trigonometry. Let us revise. So what is the meaning of trigonometry? From two Greek words we have derived the meaning of trigonometry. So we can simplify and conclude that trigonometry is basically measurement of which triangle? Right angle triangle. Which triangle? Right angle triangle. So now we have all learned about what is right angle triangle, but let us flash back and then revise what is right angle triangle. Why? Because it's very important to know this about right angle triangle. Why? Because we're going to focus mostly on right angle triangle only. Under trigonometry, we're going to deal only with right angle triangle. So it's first very important to know what is right angle triangle, right? So now we'll learn about right angle triangle. So do you remember what is the main feature of right angle triangle? Like, how can we identify a triangle as right angle triangle? The main feature, if I think everyone knows about it, the main feature of right angle triangle is out of three angles. We know that a triangle have three angles. That's why the name itself is triangle. So we have three angles. Out of those three angles, one angle measure 90 degree. This is the main property of right angle triangle. So this 90 degree is also known as right angle. So if I draw on figure one triangle, this triangle can be said as right angle triangle only if out of these three angles, if one angle measures 90 degree, then we can say this triangle is right angle triangle. So the main feature or the main characteristic or the main property of right angle triangle is one angle out of three angles, one angle will always measure 90 degree. That is right angle. Now what about the other two angle? As per this example, if we give 90 degree to B, the other two angles are A and C. So what will be the measure of these two angles? So let us try to know the measure of these two angles. Do you remember the sum of all angles of a triangle? The sum of all angles of a triangle. As part of this example, we have angle A, angle B, and angle C. So if we add up all these angles, what will be the measure? The measure will be 180 degree. This is one of the property of triangle. So the sum of all angles of a triangle is always 180 degree. So using this property, let us try to know the measure of this missing value, the missing angle A and angle C. So we know that the sum of all angles of a triangle is 180 degree. From this 180 degree, this 180 degree will be divided into angle A, angle B, and angle C, right? So from here angle B has already taken away 90 degree. Angle B has already taken away 90 degree. So 90 degree belongs to B. Now how much angle is left out? How much angle? See, from 180 degree, total is 180 degree. From there, angle B has taken away 90 degrees. So how much angle is left out? 90 degrees left out, right? So 90 degrees left out. So this 90 degree will be divided among how many angles? Angle B, it took the share, right? So angle A and angle C is left out. So this 90 degree which is left out will be divided among A and C. This will be divided among A and C. So now, how are we going to divide? How are we going to divide this 90 between A and C? First, we need to know that we can never have a measure of 0 degree in an angle. We can never have a measure of 0 degree in a triangle, not angle. 0 angle we have, but in a triangle we cannot have 0 degree. Okay, so the combination can never be 0 degree to A and 90 degree to C, or 90 degree to A and 0 degree to C. This is impossible, because in a triangle we cannot have 0 degree. So how are we going to make the combination? Combination can be made in many ways, but let us just take few examples, only few examples, but we can make in many ways. So angle A, I can give angle A 30 degree. So we have 90. From there, if I have given 30 degree to angle A, the leftover angle is 60 degree, right? So angle C can take 60 degree. Or we can also make one more combination, 45 degree to A. So what will be left for C? 90 minus 45, which is equal to 45. So C will have 45. We can also make more combinations we can make, but we are just trying to find out the measure of angle A and C using these two examples. Okay, so now in these two combination, if we observe, in these two combinations, if we observe the measure of these two angles, the measure of these two angles A and C, both are less than 90, right? Both are less than 90 degree. Yes or no? Both this A as well as C, if you, even if you make more combinations out here, all the combinations, in all the combinations, you will always observe that A and C are less than 90. You can experiment at home, you can make more combinations, but you will observe that in all the cases you will find angle A and angle C, the measures are less than 90 degree. And this less than 90 degree is known as, we have some name for this, less than 90 degree is known as what angle? Is known as acute angle, right? Even this we have learned in lower classes. So less than 90 degree are known as acute angle. And what about 90 degree? Exactly 90 degree is known as what? Right angle, right? Exactly 90 degrees known as right angle. So from here, can we conclude that in a right angle triangle, we have one right angle, and we have two acute angle. We have two acute angle. Acute angle means less than 90 degree. So we have made an important conclusion out here. For a right angle triangle, we have made a conclusion that in a right angle triangle we have how many right angles? We have one right angle. And how many acute angles? Acute angle means less than 90 degree. We have two acute angle which is less than 90 degrees. So in this example, angle A and angle C will be acute angle. Angle A and angle C will be acute angle. Let's take more example. Let's say this is a triangle and we have 90 degree out here. So this is PQR. So which angle is right angle? Angle P is right angle. And which two angles will be acute angle? Angle Q and angle R will be acute angle. Okay, so I hope this is clear. Now we'll move to next important topic, that is trigonometric ratios. Trigonometric ratios. We have 6 trigonometric ratios which you need to remember. We have 6 trigonometric ratios. So what are they? Sine theta. This is known as theta, and this is also a Greek term. It is not compulsory to use theta out here, but in most of the textbooks we have theta. We might also have sine. We can also write this as sine A, we can also write this as sine X, we can also write this as sine P. So we can use different terms, but usually we use, while deriving the formulas, usually we use theta. Okay, so this theta is also a Greek term. So what are those 6 trigonometric ratios? The 6 trigonometric ratios are sine theta. The opposite of sine theta is cosec theta. I'll be writing in the straight line. The opposite I'm writing in the straight line, so it will be easy for you to memorize the formula. Sine theta opposite is cosec theta. Cos theta opposite is sec theta. Tan theta opposite is cot theta. So how many trigonometric ratios do we have? We have 6 trigonometric ratios. They are sine theta, cosec theta, cos theta, sec theta, tan theta, cot theta. Okay, so here if I write down P, this P will represent perpendicular. This P will stand for perpendicular, because I'll be using short form in formulas. H, if I write H, this H will represent hypotenuse. And then B will represent base. So the formula of sine theta is P by H, that is perpendicular by hypo, ratio. This is a ratio, P is to H. And then cosec theta is, since I said opposite of sine theta, this will be H by P. Just reverse reciprocal. Cos theta is base by hypo. And this will become, since it's opposite of sec, opposite of cos, so it will be H by B. This is P by B, and this will be B by P. They are opposite. Okay, I can say opposite. So now these are the formulas which you need to memorize. Now let us discuss about what is the meaning of this perpendicular, hypotenuse and base. This is very important. We need to know the meaning of these terms. Very, very important. Okay, so now let us first know the meaning of this perpendicular, hypotenuse and base. See, at the beginning of the topic I said that trigonometric ratios will be applied only in right angle triangle, right? So I'll be drawing one right angle triangle and name this as ABC. So right angle triangle have one angle which measures exactly 90 degrees. Now let us first know the meaning of the term hypotenuse. I wrote three terms in the previous slide. That was hypotenuse, perpendicular, these are the terms which are used in the formulas, and base. Okay, so let us first know the meaning of these terms. Hypotenuse is basically opposite side of right angle. So what is right angle? Now right angle is 90 degrees. I hope I hope you know the meaning of this side. Side means in triangle we have three sides, right? The sides are AB, BC and AC. Very simple. AB, BC and AC. So opposite side of right angle, that is hypotenuse. So we have right angle out here, that is B. B is right angle, right? So what is the opposite side? Opposite side means this one. This is the opposite side, right? Opposite side. So opposite side of B is AC. Yes or no? The opposite side of A is, oh sorry, angle B is AC. So hypotenuse will be in this example AC. Let us know with more examples. Let's say this is a triangle PQR and I've given 90 degree to P. Now in this triangle, which one will be hypotenuse? Let's know the definition first. Opposite side of right angle. So where is right angle out here? The right angle is at P, right? The right angle is at P. So what is the opposite side of angle P? Opposite side is QR, right? The opposite side is QR. So we can say in this triangle hypotenuse is QR. One more example. We need to have the clear meaning of this term XYZ. Let's say Y is 90 degree. Now can you tell me which one will be hypotenuse? The hypotenuse out here will be XZ. Why? Because the opposite side of right angle is XZ, right? So I hope you are clear with the meaning of hypotenuse. So now let's move to perpendicular. Perpendicular is opposite side of acute angle. Now just now we have learned that in a right angle triangles, how many acute angles we have? We have two acute angles, right? So in this triangle, angle B is 90 degrees, so the leftover angles will be acute angles. So angle A is also acute, angle C is also acute. Now for perpendicular, we should first select acute angle because we have two acute angles. So we cannot look from these two angles at one time. We cannot look from these two angles at one time. We need to select one angle, one acute angle, and then we need to locate perpendicular. So if we are selecting A as acute angle, our perpendicular will be what? See, perpendicular is opposite side of acute angle. So the opposite side of acute angle A is BC, right? The opposite side of acute angle A is BC. This is the opposite side. So BC will be our perpendicular only if we select A as acute angle. So let's say we are changing the acute angle. To C. Now we are looking from C. So we have selected C as acute angle. So now can you tell me what will be the perpendicular? Perpendicular is the opposite side of acute angle. Whichever acute angle we select, the opposite side is perpendicular. So our perpendicular as per acute angle C will be B. Sorry, AB. So that means we cannot say a perpendicular is a fixed side. We cannot fix a perpendicular. According to acute angle, according to the selection of acute angle, we will locate perpendicular. Let's take more examples. We are drawing one more triangle out here and name this triangle as MNO. N is 90 degree. Can you tell me which one will be hypotenuse? Hypotenuse is the opposite side of right angle. So hypotenuse is NO. Now these two angles are acute angle. Let's say I've selected O as acute angle. So as per O as acute angle, what will be perpendicular? Perpendicular is the opposite side of acute angle. So as per acute angle O, our perpendicular will be MN. our perpendicular will be mn. But if we change the acute angle, and if we select n as acute angle, then our perpendicular will be MO. Now you might have one doubt. That, like, how are we going to know which acute angle we are going to select? That's the main doubt, because we have two perpendiculars in a triangle, right? Because if we change the acute angle, the perpendicular changes. So now which acute angle we are going to select, that topic again we'll learn after completing the meaning of hypo, perpendicular and base. That will be very simple. After learning the meaning of hypo, perpendicular and base, we'll go back and learn how are we going to select the acute angle, how are we going to know that this is the acute angle which we need to select. Okay, as of now, just remember that perpendicular is opposite side of acute angle. Okay, and please remember that we cannot have a fixed perpendicular. If we change the acute angle, then the perpendicular changes. Okay, now let us go back topic and then learn the meaning of base. Base is adjacent side. Now I'm not writing opposite. Okay, adjacent side of acute angle. Now what is adjacent side? Adjacent side is basically the nearby, not the opposite, nearby side. Actually the meaning is different, but just for you to understand, we can say adjacent side are the nearby sides. Okay, now if I draw a triangle, right angle triangle, so A, B, C, this is 90 degree. Now let us first know about what is adjacent side. Let's say angle A. What are the adjacent sides to angle A? For angle A, what are the adjacent sides? Adjacent sides are basically the arms, but just remember that adjacent sides, for your understanding, it's nearby side. So adjacent sides for angle A is AB, because this is the nearby side, right? This is the nearby side, and as well as AC is also adjacent side. We have two adjacent side for one angle. Okay, remember that. BC is opposite. BC is the opposite side of angle A. BC is the opposite side of angle A, but adjacent is AB, because AB and AC are nearby sides. Right? These sides are near to angle A. What about adjacent sides to angle C? The adjacent sides to angle C will be BC and AC. I hope you are clear. The opposite of angle C will be, the opposite side will be AB, but adjacent will be BC and AC. I hope this is clear. Now what does the definition says? Definition says adjacent side of acute angle. Now even here we need to select acute angle, because we have two acute angles in a right angle triangle. So we need to first select an acute angle and then locate base. So let's say we are selecting A as acute angle. So as part is acute angle A, which one will be our base? Definition says adjacent sides, right? So now you might be confused that just now I said that we have two adjacent sides for one angle, right? We have two adjacent sides for one angle. So the adjacent sides of A is AB and AC. So now which one will be base? Very simple. AC is already occupied by hypotenuse, yes or no? Because the opposite side of right angle, is hypo. This will not change. So this AC has been occupied by hypotenuse. So we are left with only AB, yes or no? We are left with AB. So AB will be our base. Very simple. The adjacent sides of acute angle is AB as well as AC, but AC has been occupied by hypotenuse, so our base will be AB. As per the acute angle A. Let's select C as acute angle. Let's shift the acute angle and then select C as acute angle. As per this acute angle C, which are the adjacent sides? Adjacent sides are BC and AC, but AC cannot be said as base because AC has been occupied as hypotenuse, right? So what will be our base? Our base will be BC. So this AB is the base as per acute angle AB, and this BC is base as per acute angle C. So let's revise the meaning of hypo, base and perpendicular using one more example. This will be the last example related to the meaning of hypo, perpendicular, base. Please try to clear all the doubts using this example. Okay, let's see, this is PQR and this is 90 degree. Okay, so what will be the hypotenuse? The hypotenuse is the opposite of right angle, so hypotenuse is QR. Okay, let's select Q as acute angle. We are selecting Q as acute angle. selecting Q as acute angle. So as per Q as acute angle, what will be our base? What will be our base? Base is adjacent side, not opposite. Base is adjacent, the near one. So we have the near one sides to Q are PQ and QR, but QR has been occupied by hypotenuse, so our base will be PQ. What about our perpendicular? Perpendicular is the opposite side of acute angle. Whichever acute angle we have selected, the opposite side is perpendicular. I hope now it's clear. So now we'll go back and learn like how are we going to select the acute angle, because that's the more I think that's the most confusion part that you have, that how are we going to know which one is which acute angle we're going to select. So now let's go back to that ratio, trigonometric ratios. Here if you see these terms theta and all, this theta, if you see this term theta, these terms which are attached with the trigonometric ratios, these are our acute angles. These are our acute angles. Don't get confused. We'll try to clear the confusion using more examples. These are our acute angles. For example, if we have sine A in the question, and then let's say we have this diagram has been given in the question, ABC. So just now what I said, the term attached with the trigonometric ratio is acute angle, right? This will be our acute angle. So we got a clear idea that A will be the acute angle which will be selected. A will be the acute angle which will be selected. So as per acute angle A, what will be our perpendicular? Perpendicular is the opposite side of acute angle. So this will be our perpendicular. Since this is 90 degree, this will be our hypo, and whatever is left, it will be base, yes or no? Or we can say the adjacent of angle A is this, AB, this will be our base. Clear? Very simple. If in the same question, if it was let's say sine C, if it was sine C, that means this is our acute angle. The term attached with the ratio is acute angle. That means we need to look from C point of view. So just remember that the term attached with the ratios are acute angles. If we have cos x, that means x is our acute angle. If we have cosec y, then y is the acute angle. Okay, simple. Okay, now we'll learn one more topic that will be the last topic of our discussion, and that is also very important for us to solve questions related to trigonometric ratios. So the last topic is Pythagoras theorem. Pythagoras theorem was developed by the person Pythagoras. This Pythagoras is the name of a person. He developed this theorem, so the name of the theorem is Pythagoras theorem. Pythagoras theorem is also applicable, or we can say used only in, or applicable or used only in right angle triangle, like trigonometry. Trigonometry is also used only in right angle triangle. Similarly, Pythagoras theorem is also applicable or used only in right angle triangle. Please remember this, only in right angle triangle we can apply Pythagoras theorem. So now we have a clear idea that Pythagoras theorem, where to apply Pythagoras theorem, where to apply in right angle triangle. Now when to apply, this is also a question, right? When to apply, like in what condition we are going to use Pythagoras theorem. Very simple. If we have one triangle, first of all, this triangle should be right angle triangle. Only then we can apply, right? Where to apply? In right angle triangle. First of all, this triangle should be right angle triangle. Now when to apply? See, in questions they will provide us the informations of two sides. Let's say this side is 4 centimeter and this side is 3 centimeter, and we need the information of this side. We need the information of side PR. So whenever we have right angle triangle, and whenever we are provided with any two sides, the information of any two sides informations are provided. If we want to find out the information of the third side, the length of the third side, then we can use Pythagoras theorem and find out the third side. Then we can use Pythagoras theorem and find out the third side. For example, one more example. This is a triangle XYZ, xyz. First of all, it should be right angle triangle, and let's say we have these sides, this side as 6 centimeter and this side as 8 centimeter, and we want to find out this side. Then even here we'll apply Pythagoras theorem, because just now I said that whenever we have right angle triangle and we have the information of two sides and we want to find out the information of the missing side, then we will apply Pythagoras theorem. So I hope now you are clear where to apply in right angle triangle and when to apply to find out the missing side when two sides are given, okay. Now how are we going to find out that side? That we'll learn while solving the problems, okay. Just remember that Pythagoras theorem, it is applied in right angle triangle, and when to apply to find out the missing side when two sides are given, okay. So what is the theorem? What does the theorem states? The theorem states that this is the formula, okay. This is a very important formula that we derive from Pythagoras theorem. Hypotenuse square is equal to perpendicular square plus base square. So this theorem we are going to use to find out the missing side when two sides are given in a right angle triangle. Please remember this. The Pythagoras theorem states that this is the formula that we are going to use, okay, while trying to find out the missing side. Hypotenuse square is equal to perpendicular square plus base square. Okay, let us quickly revise what we have learned today. We have, first of all, we have learned the meaning of trigonometry. What is the meaning of trigonometry? Measurement of right angle triangle. That is, basically we are going to find out the sides, the angles of a right angle triangle. Next, we have discussed about right angle triangle. In right angle triangle, we have how many right angles? We have we have one right angle. And how many acute angles? Please remember this, we have two acute angles, okay. This is the main property of right angle triangle. Next, we have learned about ratios, trigonometric ratios. How many trigonometric ratios do we have? We have 6 trigonometric ratios. And what are they? They are sine theta, cos theta, tan theta, cosec theta, sec theta, cot theta. And what is the term attached with that ratio known as? These terms are known as acute angles, right? These terms are known as acute angles. After that, we have learned the meaning of hypotenuse. Hypotenuse is opposite side of right angle, perpendicular is opposite side of acute angle, and base is adjacent side of acute angle. And how are we going to select this acute angle? By simply viewing the trigonometric ratio. If it is sine theta, theta is the acute angle. If it is cos x, x is the acute angle. If it is sine a is the acute angle. And then lastly, we have discussed about Pythagoras theorem. And Pythagoras theorem, we will be needing it in most of the question. Where to apply Pythagoras theorem? In a right angle triangle. When to apply? To find out the missing side when two sides are given. And then the theorem states, the formula is hypotenuse square is equal to perpendicular square plus base square. Okay, thank you.